Okay, so after today's math class, I got some people after today's MTH 1 2 3 class. Some people asked me questions like I believe at the end of the class the lecturer give us some work to do. People ask me questions like how can they generate two vectors to have the same magnitude? Number one. And the second one is the one that plenty people a lot more people asking was how can you generate two vectors that have the same direction? First of all, let's start with magnitude. You have to first of all pick the magnitude that you want. Let's pick a magnitude of n. So we want to find two vectors irrespective of the direction, but they have the same length. Good. Now how do we do this? How do you define the length of the magnitude of a vector? The magnitude of a vector, that is the magnitude, let's say this vector is vector A. The magnitude of vector A is equal to the square root of the sum of the squares of its components. Yeah, that's basically the whole thing. The square root of the sum of the squares of the components. So you have square root of x squared plus y squared plus z squared. Square root of x squared plus y squared plus z squared. So if you want two vectors to have the same components, then the square root of x squared plus y squared plus z squared must be the same. Now let's pick a vector. Let's say the vector is m. Let's pick a magnitude. Let's say that magnitude that we're looking for, that we want the two vectors to have, is m. So m should equal to the square root of x1 plus y1 squared plus z1 squared. And this should also equal to the second vector, which is x2 squared plus y2 squared plus z2 squared. So first of all, you can just pick random values for x and y. Just pick any random value for x and y. Then equate it. That is, you square both sides, you will now get m squared. Your m is already known. You are the one that will pick the value of the magnitude that you want. M is already going to be known. X1, you randomly pick what you want x1 to be. Y1, you randomly pick what you want y1 to be. Then z1, after you square both sides, you have m squared minus x1 squared minus y1 squared is equal to z1 squared. By the time you square root both sides, you have the square root of the magnitude that you picked squared plus the x component squared plus y component squared, and you have the z component. So now that your vector, now that you have gotten the random x that you pick, the random y that you pick, and the soft z that you pick, will all have a magnitude of m. You do the same thing for x2, y2, and z2. You randomly pick a value for x, you randomly pick a value for y. This vector will also have the same magnitude as this vector. Now, if you don't want to do this, there's another easier method. Maybe you don't want to randomly pick values and start solving all this. There's another easier method that you can use to get two vectors that have the same. But this method is trivial. That if you have a vector A is equal to xi plus yj plus zk, you can just say the vector B will equal to yi plus xj plus zk. You see, I've changed the lettering, but the magnitude here will be the same thing as the magnitude here. So these are just ways you can generate magnitudes that are the same. Instead of exchanging only the x and y, you can even exchange the whole thing. You can exchange the whole thing as saying maybe yi plus zj plus xk. This vector will have the same magnitude as this vector. So that's just the general ways you can do it. You can either pick the magnitude that you want, randomly pick the value for x and y, then solve for the value of z. Do the same for the second vector, randomly pick the value for x2 and y2, then solve for the value of z2. Then you have gotten two vectors that have the same magnitude. Or use the second method, you just randomly pick x, y, and z to be the first vector, then switch the components to maybe yi plus zj plus xk, and that's another vector that have the same magnitude. So that's one way of doing it. So for the second question now is another more sweet question. That question asks us that, or tells us that, how can you get two vectors that have the same direction? This time now the magnitude does not matter, so they just be in the same direction, and that means their unit vector, the unit vector of A and the unit vector of B, must be the same. That's just what it means for them to be in the same direction. Like, unit vectors must be in the same direction, they must be the same. Okay, now if you want the unit vectors to be the same, each unit vector A is equal to cos theta I plus sine theta j. So you can pick a random value for cos theta, pick a random value for sine theta, or rather just pick a random value for theta, then get what cos theta is and what sine theta is, and you have gotten a unit vector. Now all you have to do is to multiply this unit vector by a magnitude. If I multiply this unit vector A by maybe the magnitude of 5, let's say 5, and let's say the theta I picked here was, let's say let's say I picked here theta here to be 4. No, not 4. I cannot get cos 4. Let's say I pick 30. Let me just pick it's something I can easily get. Let's say I pick 30. Cos 30 is equal to root 3 over 2I plus sin 30 is now equal to half j. So this is the unit vector. Good. That is pointing in the 30 degree. So if I multiply this by 5, I have 5 root 3. Well, let me write it in line with this. Let me just write it vertically, because I cannot write while bending the board. So let's say vector A is now equal to 5 root 3 over 2I plus 5 over 2j. This vector now. Now let's say I want another vector that has a magnitude of maybe 4. So I have 4 root 3. Okay, that's 2 we cancel. So that's just 2 root 3I plus the 4 here we cancel, that is 2j. So 5 root 3 over 2I plus 5 over 2j is always going to be in the same direction as 2 root 3I plus 2j. That is one way of generating vectors that are in the same direction. So these two vectors are in the same direction. First of all, use this formula, cos theta I plus sin theta j, put a random value for theta that you want, then get that cos theta and get sin theta. You've gotten the unit vector. Multiply it by any length you want. It can even be 0.5. It can be less than 1. It can be greater than 1. But no matter what length you want, those two vectors will have the same direction. The second way you can do it is, but before we can do that, before we do that second way, let's look at something here. This 2 root 3 here divided by root 5 root 3 over 2 would give you, okay, let me do it the other way around. This here divided by this would give you 5 over 4. And this here divided by this will still give you 5 over 4. So if you've noticed, these two, even though they may look different, they are just different by a common factor. That is 5 over 4. So that's where this second method comes in play. This is one way. I showed you two methods to generate two vectors that have the same magnitude, but only two easier methods. The second way is if you pick random values for your first one. Let's say the one I told my course rep to pick. She picked 2I plus 3j. How do I still remember this thing? Okay, she picked 2I plus 3j plus 4k. Okay, actually, there's a because of just 2, 3, 4. But okay, 2I plus 3j plus 4k. If you multiply this by any factor, let's say I multiply by 2, then b is going to equal to 4I plus 6j plus 8k. So now these are two vectors that are going to be in the same direction because they have a factor. In fact, it's even explained in my this thing. There's a book I'm writing now. Some of you already know about it. I explained some of this inside that book. So yeah, the way the book is going to work, I want it to be like a weekly something that you can get the book off from me. It's just going to be 500 naira. I know things are hard in the country, but just 500 naira. You can get the book off from me every week. It's not compulsory for you to buy the book every week, but every week there's going to be an update to the book. Every single day I'm always adding something new to the book. I'm always adding diagrams, something new, more explanations, discussion, and the rest. So every week I'm coming to renew your book, but you can just stay with the version that you have for maybe 2 weeks before you renew, or 3 weeks, or no matter how long you want it to be. But as always, the people in mechanical engineering will obviously get the book for free because they're in my department. But all this was explained in the book. Let me get it open. Okay, this is the book. Very glorious book, packed with important information on the vectors. But let me get to the part where I showed what I just finished explaining now. Okay, this is it here. Okay, under the book, you will get it under unit vectors. These are special vectors that have the magnitude of 1, thus the name unit vectors. Their length is what defines them, so they can point in any direction. Remember, to specify a unit vector, you need length and its direction. While to specify a vector, you need its length and direction. This direction can be represented as the unit vector in that direction, which is a cap. Therefore, the vector is equal to the magnitude times the unit vector. So unit vector is described as that vector divided by its magnitude. So if you have a vector blah blah blah, you can see all this. Okay. Now this was my diagram that I had inside the book. You can see that these two vectors, vector A, vector V, they all point in the same direction. And that is because their unit vector A cap is equal to its V cap. All these were made before even the class. So even if you never attend the class, you would have seen this and been able to grasp it. So this is it. In fact, if you want to find a vector that is in the same direction but with a different length, you can even see the time. When did the class end? This is 5:59. Okay, that's actually 1 hour after the class, but it's not possible for me to have written 34 pages 1 hour after the class. So consider this book was actually written since this is my second week now that I'm still writing the book. I know I'm slow. I'm still 34 pages, but yeah. Why can you do that if you are giving the new max? Okay, this is it. This vector A will have a magnitude of A, and the vector V will have a magnitude of that modulus V. For them to be in the same direction, A cap must equal to V cap. And I went further to say, if vector V has a specified magnitude and direction, i.e. vector V is equal to the magnitude times its unit vector, and vector A is equal to its magnitude times unit vector, but we don't know what vector A is. We only know vector A's magnitude, and we know vector V's magnitude, and we know vector V unit vector. Then we can generate any vector in that direction of V just by saying the magnitude of V the magnitude of A divided by the magnitude of V times that vector V. The magnitude of A times divided by the magnitude of V times that vector V. In fact, there's no even need for you to you can just see the second formula that I put inside bracket. I put two formulas inside square bracket. You can just use this other formula. Just pick any scalar, multiply by that vector, and you have gotten a new vector that has that same direction. Now, the second method I used was for the component. This method is basically under the same thing. If you have a vector here multiplied by a scalar, but it just in case you are told to have a specific something, like if you are told the new components, the specific components that they want. So yeah, this book is very powerful. It's something that if I didn't know anything on that vector, I would actually purchase. But it's still a choice in case you still want it. Then yeah, thank you so much. So excited.
Excited.